Hi, everybody. So today I'm just going to go through um, the way that you need to show your calculations in science. And this is going to be true for any science class that you take. And you just got to follow these rules. And some people will argue that they don't need to do all this because they can do it in their head. And it's not that I doubt your mathematical abilities by any means. The reason you have to show your work is because the reader needs to be able to follow what it is you're doing. So if just some random number shows up without any formula or anything, it's just like, okay, what is this? So anyway, let's go and take a look at that. So here we are. All right. Okay, so showing your work, this is what you need to do. The first thing you need to do is show the formula. You have to show it. If you do your work and there's no formula, then you're not going to get any points because I don't know what it is you're solving. All right. However, there are times when there isn't a formula. And if there isn't a formula, but you still have to do a calculation, then you need to actually design a formula on your own. For example, if I were asking you to find an average, you could come up with a formula that looks like this. So I have 5 diameters and I need to find the average diameter. So I would have all 5 diameters at the top over 5, and that would give me my average diameter. So that's the first thing you need to do is show your formula. Your formula might be density is equal to mass over volume, whatever the formula happens to be. Now, in this particular case, the unknown is out here on the left, the D average. This is always where your unknown needs to be. Oh, but Ms. Millender, I could do it without manipulating it, so don't worry. No, I know you can, but you have to, because from the outset, the reader should know what it is you're solving for. So again, you have to. But for example, this is a difficult one to do it with. So let's look at the density formula. You have density as mass over volume. So that's great for calculating density. However, what if you're given the density and the volume and it asks you to solve for mass? Now, I know you could do this without manipulating the formula, but the rule is you need to manipulate the formula. So I am going to get mass is equal to density times volume. And if I wanted to solve for volume, I'm going to have volume equals mass over density. So this is how they have to be set up because this is the thing you're solving for and it's on the left side of the equation, right? Okay, then once you have the formula, you substitute numbers in for it. So you've got your average diameter formula. I plugged in what the diameters were. So I just plugged those in, that's step 2. Step 1, you wrote the formula. Step 2, you plug the numbers in with units, by the way. So units, units, units. Okay. Then when you finish the math, you have to show your answer with the proper units and sig figs. So here's your formula, here's your substitutions. When I did this math out, this is what I got. And with sig figs, you can only have 3 sig figs. So this is what you're going to get for your average. Actually, that's not fair to say. It's not that it's 3 sig figs, it's that it's 2 decimal places. So, and this is 2 decimal places because it's an adding problem. And that's why in that you round to the decimal place of the least precise first best guess. And we'll talk more about this. You'll get it. I'm not worried. So let's do another example. This example should go in your notebooks, just like the other example should go in your notebook. So this Archimedes story, whoops, nope, sorry. So Archimedes knew the density of gold to be 19.30 grams per milliliter. He used water displacement and he determined the volume of the crown to be 85.6 milliliters. So now he should be able to calculate what the mass should be and then compare that mass to the actual mass and see if he was cheated by the goldsmith. All right. So the question is, what is the mass of the crown? So here's what I do. And I think it's a really good habit to get into, but it's up to you. I'm not going to check on this, but I really think it's a good way to go through things. In a word problem, circle the numbers and the units you're given. So, whoops. So the first thing we're given is this 19.30 grams per mil. You could go back and read this, but just from the units, you know that that number is a density. So you circle it and write what variable it represents, okay? Then I have this 8.56 milliliters. Again, you could read this, which hopefully you've already done, but looking at the unit, the milliliters, you know that that's a volume. Then, well, what's the question? What is the mass? So I underline mass and I put a little question mark with the variable. So I'm looking for mass. I have density and volume. What it does is it prevents you from having to read through the whole thing again. And I think it's a good habit to get into. Anyway, so we have the original formula, which is density is mass over volume. Well, I don't want that. I want mass by itself. So I need to get rid of the V on the right-hand side. And most of you will know that I have to multiply both sides by V. All right. The V on the right cancels, but now I'm writing it so that the M is by itself on the left. So M is equal to D times V. You could put V times D. It doesn't really matter. So this is the formula that I'm going to start with. Okay. So there's Archimedes being very excited. So I've manipulated the formula so that the unknown is on the left, thing I'm solving for. I substitute the numbers in and I pulled these right out of the word problem. And I just multiplied those. I got this 1652.08. But as I look up here, there are 4 sig figs here. There are 3 sig figs here. So I want 3 sig figs in my answer. I count over 1, 2, 3. So the 5 is my last sig fig. Is the 2 going to round the 5? Nope. So I have to put in a 0 there to hold the place, because you can't round 1,652 to 165. I mean, they're not even in the same ballpark. So anyway, that's a sig fig problem, but that's what you need to do to show your work. You have to show those steps for the rest of the year, for the rest of your science classes. Okay, and you'll get 100. You got to put units, you got to put the stuff in the right place. You will actually earn more points. If you just put down an answer, you won't get any points. So even if it's right, so you have to show the work. It's as important, or sometimes even more important, than the actual answer. Okay, so that is how you show your work, and thanks for watching.